All right, so we're going to talk about absolute value inequalities. I'm going to make this short, as sweet to the point as I possibly can. So absolute value inequalities. You have two types of absolute value inequalities. So if you have an absolute value, in the first example here that it says is greater than or equal to 5, what you need to know is that the absolute value inequality will state that it's OR. So the absolute value, okay, so you have what is called the absolute value. So if you have the absolute value of some value is greater than or equal to A, then, okay, that X is greater than or equal to A, or, okay, you can claim that the opposite of X is greater than or equal to A. So the most important part here, though, is that this word OR is being used. So greater than are OR compound inequalities. So why are they compound inequalities? Because when doing absolute value, we've talked about this a bunch of times, that absolute value creates two equations, okay? So two equations. So what you need to get out of today is that the greater than is an OR compound inequality, but the and, so if you have the absolute value of X, which is less than or equal to A, then, okay, X is less than or equal to A, and the opposite of X is less than or equal to A. So what's important here, okay, is the idea is that if it's a less than, it's an and compound. Okay, now why does that matter? Because or compound inequalities that we have studied and will continue to study are these things of disjunction, which means you have one going that way, one going that way to the right, and you've got some space in the middle, where an and compound inequality was this bar that we were kind of dealing with in the middle. So with that being said, I'm not going to do the graphs of these ones. I'm just going to get into the problems. What you need to know here is that all absolute value inequalities didn't spell that right. So all absolute value inequalities are hidden, or special, I'm going to use, are special compound inequalities. Now, again, by definition, what are compound inequalities? Compound inequalities are two or more inequalities. So you have the definitions over here. The absolute value of X, if it's greater than, you really want to focus on the word or, and if it's less than, you focus on the word and, right? But notice that they set up the exact same. So if the absolute value of X is greater than A, well, X is greater than or equal to A, or the opposite of X is greater than or equal to A. If it is a less than, it is the absolute value of X is less than A, and the negative X is less than or equal to A. All right? So, basically there's steps to solving these. Like as every other absolute value, you have to isolate the absolute value. After you isolate the absolute value, you can create your two cases. And then after you create your two cases and solve both of those inequalities, you can graph your solution. And if you want to write it as interval notation, you can go ahead. All right, so let's focus in on numbers 1 through 4 here and solving these and get to it, okay? So here we go. We have an absolute value less than 7. So what's important here is that we can claim, based upon the property of absolute value, all right, that the X is less than 7. And because it's a less than, we use the word and we do negative X is less than 7. And then from here, we solve both of them. So the first one is solved by natural, okay? And then the second one, we have to divide by -1, divide by -1. Just remember, when you divide by a negative, okay, you've got to flip that inequality. So what I end up getting here is that X, okay, in this case, X is going to be greater than -7. So I have a number in which is less than 7 and, and greater than -7. So my boundary points, right? So my boundary point is one of them is at 7. So I'm going to go over to the graph here to the right, and the other one is at -7. So one of these is greater than -7, so that's to the right, and to the left of 7, right? So we shade in between. So if you notice, this is the and compound inequality, all right? So this is one of the most common ones. It is the most common type of and, all right? It is the conjunction, all right? So you don't have to worry about it. What you need to know for absolute value less thans, they will all be the most common type compound conjunction inequality. Now, let's take a look at or. So if I have absolute value of x, then I would claim that x is greater than or equal to 4, or negative x is greater than or equal to 4. Now, we can go ahead. The first one is naturally solved, but let's go ahead and solve the second one. So we divide by -1, divide by -1, and we end up with that x is less than or equal to -4. So now the word or is important, okay? And the reason for it, again, is because we can choose one of these at a time, right? Like there is no number that's greater than 4 that is simultaneously, then less than 4. That's the idea of or. So or allows me to do one of these at a time. So the absolute value greater than is always going to be the compound inequality disjunction, which means it's going to be the most common one that we saw before. Now, because it's equal to, we're going to put a solid circle at the -4, a solid circle at the 4, and because it's the disjunction, we shade to the left, and then we shade to the right, and then we're done, okay? That's it. That's all it is. The biggest part about this, honestly, for these problems is going to be the word and the word or, okay? When we get to the Keystone exam, they're literally going to have these same exact problems, same exact answers, except the difference will be one will say and in between them and one will say or in between them. There won't be a graph. They're just going to look for the answer. They're going to ask you to solve the problem. It's going to be a multiple choice. One will say and, one will say or. So you got to do your best that you can for absolute value. Less than is an and, greater than is or every single time. So let's take a look at two more. So it says the absolute value of x minus 1 is greater than 6. So because it's a greater than, I'm just going to use the word or in between my two things. So x minus 1 is greater than 6, or, going into my second case, I've got the positive case. Now I'm going to create the negative case, which means I basically take a negative in front of a parenthesis and go x minus 1 is greater than 6. So now I solve both of these. So the first one, add 1 to both sides, add 1 to both sides. I get x is greater than 7, or... Now, the second one's going to take a little bit more because I got to do the distributive property. So I'm actually... so distributive property, so distribute that -1. So I get negative x plus 1 is greater than 6. I'm going to subtract 1, and I end up with negative x is greater than 5. And then the next thing I'm going to do is divide by -1, divide by -1. Just remember, when dividing by a negative, you got to flip that inequality. That becomes so important that you remember that piece. So instead of being a greater than, it's now less than -5, Now, you'll also see why these words or and matter, right? There is no number, like logic, right? There's no number that's greater than 7 that's going to be less than a negative. Like, you can't tell me a positive, even just random numbers, without even keeping the positive in mind. You can't be greater than some positive, but yet less than a negative. It doesn't happen on a number line, right? So the word or matters. It allows us to keep these things to separate from one another, disconnected, disjunctioned from one another. So I can pick values for x that are greater than 7 at one time, and then I can choose to switch over and pick numbers that are less than -5 at another time. They don't have to be connected. Okay, so here we go. Let's go ahead and put that in there. So at -5, I will have an open circle. At 7, I'll have an open circle. So at -5, I shade to the left. Oops. So at -5, I shade to the left. And at +7, I shade to the right. And then the problem is done. Number 4. So let's take a look at number 4. Again, it's a less than. So I'm going to write the word and, not the word or. Okay. So for this one, I get x plus 2, okay, is less than or equal to 7, and negative x plus 2 is less than or equal to 7. So then I just solve both of these. So step 1, subtract 2, subtract 2. I get x is less than or equal to 2, and then I'm going to go ahead and do this one. I'll do distributive property. So negative x minus 2 is less than or equal to 7. I'm going to go ahead and add 2. Add 2. This puts me at negative x is less than or equal to 9. And then from this point, what I'm going to do is divide by -1, divide by -1. And I will get, again, just a reminder here, right? When you divide by a negative, you got to flip the inequality. So x is greater than or equal to -9. So again, why is this important? Because and is conjunction, right? Are there points, okay, that are greater or less than 2 but greater than -9? And the answer is yes, there are, right? And in fact, if we put our boundary point at -9 and we close it in because it's equal to, and we put our boundary point at 2, right? Pick a random number. So let's pick 0, right? 0 is less than or equal to 2. That's true. And then we go to 0. Is 0 greater than or equal to -9? And the answer to that is also true. So 0, notice where 0 lies. 0 lies in between -9 and 2. This is the idea of conjunction, right? So this is why we connect the two. And that's the end of absolute value. Okay, inequalities. That's the end of as far as we go for this particular one. There are some more practice problems here that we can go over, but I'm not really going to do them. I'm just going to talk about them, and then hopefully you guys can do them in class for cool. In other words, take a look at these problems, right? So it's just some more problems with, absolute value. But notice, okay, there are some that have values on the outside. Okay, so like in number 6. So step 1, so I'm going to help you with step 1, right? Step 1, you need to isolate the absolute value, which means you need to add 1, right? The same exact way you would do an equation, right? In step 7, or number 7, sorry, step 1, okay, remember we talked about this a bunch of times. Absolute value cannot do distributive property. It doesn't hold the same properties. So the first step in this one is going to be dividing both sides by +3, okay? So number 8, there's a problem that's division. Think about what's the inverse of division. Then the absolute value will be isolated, and just keep in mind that if you multiply or divide by a negative at any point during any of these, you have to flip the inequality right then and there. A student asked me the other day, was like, well, if I divide and multiply by a negative one time and then divide and multiply by a negative another time, do I have to flip it each time I do it? And the answer to that is yes. Okay, you will come to problems potentially in Algebra 2 where you multiply and divide by multiple negatives in one problem, and it's literally every single time you do that inverse operation, you have to flip the inequality right then and there. Okay, so those are the examples, right? And then number 9 here, right? Like step 1 is, think about, isolating the absolute value. So think about, getting rid of the -3, then getting rid of the 10, and I would do it in that order, just for little hints and helps, okay? Other than that, that's the end of our chapter. And if you have questions, please reach out to me. These are just some classwork problems for y'all to do. So I would just, take a look at them and copy them down and do them. And if, like I said, if you have questions, just just let me know.